In this video, we'll talk about whether the formula P times the quantity Q plus R equals PQ plus PR, is that formula true or false, and explain why. This formula should look familiar other than the choice of letters. This is the distributive law, so this is a true formula. Again, you do have to recognize not only is a formula true or false, but to dig a little deeper and to help cement whether a formula is true or false, you will be expected to explain why. There are a couple things to be careful of. As far as an explanation goes, just replacing the letters and just saying, oh, it's because the distributive law is normally written using the letters A, B, and C, something like this, to just say like this is the explanation for why this formula works, is not an explanation at all. So the formula, I don't want you to attach to which letters are used in the formula. These two formulas are really the same formula. They should be viewed as exactly the same thing. So one thing that's unacceptable and will not count as an explanation for why you can do this is simply by just kind of appealing to different letters. That doesn't really get anywhere. Another type of explanation that people are tempted to go with is to simply kind of so imagine in red that that's the stuff that I've typed on a quiz or something. Some people are tempted to just draw an arrow above and to say, yeah, that's it. So that explains that this is allowed. That is also not an explanation because if you look at the earlier video, in the earlier video we were talking about something like this. X plus y quantity squared equals x squared plus y squared. And people have, in the past, said to me that the explanation for why this formula is true is because you can distribute that square, see, and they'll draw arrows to point that out. However, this is actually bogus. This formula is actually false, so this doesn't work at all. So if this drawing arrows here sort of misleads people into thinking they can do things that they cannot actually do, the arrows can't be used as really an explanation for why this is a valid thing here, because then can't you draw, if you can draw arrows here, why can't we draw arrows here? So because it doesn't work here, drawing arrows doesn't really explain anything. Now, if in your own work you really insist on drawing arrows to remind you what you're doing, I guess that's fine, but it doesn't explain what's going on. It's one thing to do it if you're just doing it to show that you're using the distributive law. By the way, you don't need to you don't need to draw arrows. Another thing that people will do is say, yes, it works, or something like that. They'll just say something like P distributes, or say that I'm using the distributive law. Again, all that's doing is recalling the distributive law. Just saying that something distributes is really basically the same as drawing these arrows up here. This is not an explanation. Also, something that's unacceptable, and I should make this one extremely clear because it is sort of the key thing that comes up, is just plugging in numbers. So let me make sure that I'm being clear about this. When you deal with a false formula, you should plug in numbers to show that a formula is false. However, plugging in numbers to show that a formula is true is not going to work. So for instance, if your explanation for this was something like 2 and then parentheses 3 plus 4, whoops, I have a little screen error again, and then you plugged in the same numbers, 2 times 3 plus 2 times 4, and you even simplified each side somehow, and you had something like this, so 6 plus 8, and you had 14 here and 14 here, and you even wrote a check mark to say, look, these numbers are the same. This is not an explanation. The thing is, this is only showing something that happens for these specific numbers, and you actually got that the numbers matched. This doesn't show that this works in general at all. And the thing is, the reason we plug in numbers into false formulas is because a formula to be true has to be true no matter what numbers you plug in. So if a formula is false, just one set of numbers not working makes it false. One set of numbers doesn't really make a formula true. Let me demonstrate this by talking about this formula. How about C plus C equal to C times C? Now, if you said that this formula is true, it's not, by the way, right? But if you said it's true and your argument for why it's true is you're going to plug in 2 for all the C's, then you'd have 2 plus 2 on the left, which simplifies to 4, and you'd have 2 times 2 on the right, which simplifies excuse me, also to 4. And this is well, I agree that 4 is equal to 4, but this little argument doesn't show that this formula is true, because we know this formula is not true. All I'd have to do is, instead of this, plug in 3 and have 3 plus 3 on the left, and have 3 times 3 on the right. And so then the left side would simplify to 6, but the right side would simplify to 9. So what you see here, it's not written out very well, but this is the work that really shows that the left side is not always equal to the right side. So just because it works one time doesn't show anything. Over here it doesn't, and so it doesn't either over here. So it worked for the numbers that I picked here, 2, 3, 4. I got 14 and 14 on the left and right side, but that doesn't show something in general. So the key point here is to make sure that you don't just appeal to a different letter version of the formula. Don't just draw arrows or say, yes, it distributes. That doesn't explain. The only, generally speaking, the only way to acceptably show and justify a true formula, for true formulas, there are only basically 2 acceptable explanations. Okay. The first is going to appeal to geometry, and then the second, generally speaking, is going to use an earlier formula in the class. So you can use an old truth to build a new truth. And there's a handful of other things, some situational things, especially for fractions that do things like involve pizza and stuff. But generally speaking, the explanation is going to use geometry or use an earlier formula. The thing it's definitely not going to do is it's definitely not going to involve just plugging in some numbers and showing that the left side equals the right side. You plug in numbers into false formulas to show the left side is not equal to the right side, and that makes a formula false. Just getting equality, we saw, for example, for this C times C equals C plus C, somebody could get incredibly unlucky, I guess, and say that this formula is true, and it's totally not true just by picking C is equal to 2. So instead of this, what we'll do is draw a picture, and I'm going to focus on this Q plus R first and draw in a stick of length Q and a stick of length R glued right next to that, so that this total stick here is length Q plus R. And then if I draw a big old rectangle with a side length of P, then this entire region I'm shading in has area P times quantity Q plus R, because I've got a height of P and then a width of Q plus R. Now instead, I could think of this area right here, which is P times Q, and then that should be added to this other area that's unshaded completely, and that's P plus R. So this shaded region here, you can think of it 2 ways. One, it's the area of the big rectangle, or here it's adding together, it's the sum of the area of these 2 smaller rectangles.